In this video, we'll look at insert operation, inserting in a circular linked list. So already in linear linked list, we have learned how to insert. So let us recall few things from there. So first of all, I will label the nodes. I'll give the indices to the nodes. Let us call this node as 1, first node, second, third, fourth and fifth node. So what are the positions I have for inserting a new node? I can insert it before first node, that is head node. So this is 0th index and this is first. This is in between second and third. This is second and this is third and this is fourth and this is fifth. So I have total 6 positions for insertion. I can insert a new node anywhere out of these 6 positions. If you remember, in linear linked list, we had 2 cases: inserting before first node or inserting at any other given position. So here we have 2 cases: inserting before head and inserting at any other given position. Whatever the position you want, you can insert it there. So 2 cases are there. Let us look at second case first, inserting at any other position. What is the procedure? Suppose I want to insert a new node at a position 4, means here I want to insert a new node. Let us insert a new node there. I'll remove this. First of all, create a new node with the help of a pointer T and insert data. Now for inserting a node here, I should link this one to 5th node and 4th node should point on this one. So I have to manipulate this 4th node also, change that one. So for that I need a pointer here. So that pointer I can bring it from first node, that is head node, and I should move the pointer 1, 2, 3 times. Then the pointer comes here. Once the pointer comes here, I can make T's next point on P's next. P's next is this 5th node, and also I can modify this pointer, that is make this P's next point on new node T. This is the method for insertion. So this procedure is same as what we have seen in inserting in a linear linked list. So same procedure is there. Let us have a look at the code once again. I'll just write on the code. Here I have written the code. I need a pointer P upon head node. Then with the for loop, move P for position -1 time. If the position is 4, so then move P for 3 times. Then create a new node. I am creating a new node and filling the data, T's data. So data is filled. Then T's next is P's next. So T's next is pointing on P's next, which was already pointing here. Then P's next is T. So P's next is pointing on T. So this is the code for inserting at a given position. The code is same as what we have saw in linear linked list. So you are already familiar with the code. Then one more important thing, analysis. This procedure takes minimum time when you want to insert here after first node. And it takes maximum time when you want to insert after last node, if this is the last node, right? So after head node, if you insert, it takes minimum time. So minimum time is constant time. So this procedure takes constant time when you want to insert here, and it takes maximum order of n time when you want to insert after the last node, right? So in a circular linked list, there is one position where we can insert in constant time, and that position is after head node. Now we will see how to insert a new node before head node. Now for inserting before head node, what are the things I have to do? Let us see the procedure. First of all, I should create a new node with the help of some pointer T. Then insert data. Then T next should point on head. Okay, this is done. But one more thing I have to do. This last node should point upon T. So I have to manipulate or modify this last node. So I should reach last node. So how I can reach last node? Take a pointer P from head node and go on moving it. And stop here. On what basis I can stop there? Because its next is equal to head. So stop on the node whose next is equal to head. So stop on that node. So P will move and stop at this node. Then what I have to do? P's next should point on new node T. So P's next, that arrow link is coming till here, you can see. So I'll extend it and make it point on T. Now if you start from head, This 8 will send on 3, 3 will send on 9, 9 will send us on 6, 6 will send us on 2, and 2 will send us on 10, and 10 is linked to 8. So this node is inserted inside circular linked list. Now one last thing. Shall I move head and call this as new head? So if somebody comes on the left hand side of head and sits there, will you make him a head? No, need not be. If somebody comes before first and sits before first, then you can call him first, new first. But a new head is not necessary. So logically, you don't have to move head. Head will be that same node. If at all you want to change, you can move that head. I prefer let the head be same node. Don't move it. Just we have inserted a new node before head node. This is same as inserting a new node after last node. What was the last node? 2. Then after that 2, who is there? 10. So this is the last node. And then it is connecting to head. So inserting before head or after last node is the same. Only the difference is whether you want to move head there on a new node or not. Alright, procedure is same. So head is your choice, moving head is your choice. So inserting before head or inserting after last, both are same. So let us write down the procedure for doing all this. I'll write down the code here. So what I need is I will create a new node and fill the data. So first I will create a new node. Node is created. Let us fill the data. Then let it point on head node. So T data is filled with the value and T's next is pointing on head. Now what I have to do is I should go on the last node and make it point on a new node T. So for that I should take a pointer P from here and make it move till last node. So for that I will have one more pointer, node P assign head. Now that should move till last node. So while P's next is not equal to head. So it will stop when P's next is equal to head. So right now P's next is equal to head. So it will stop. And every time what I should do, move P. P is assigned P's next. So P will be moving up on next node. So this loop will move P till the last node. Then that last node should point on new node T. P's next should point on T. Then if you want to move head, you can move head on new node. Head assign T. So this head node will point on new node. So this is the procedure for inserting before head or also after last. So even this procedure is also inserting after last, but this is based on the position index. So there were two cases, inserting before head or inserting at any other position. So this I can call it as inserting at index 0 and this is any other index. So let us combine these two and write a single insert function. So I will write a single insert function, then I'll explain that one. Here I have an insert function. Let us quickly look at this one. See, insert function is taking two parameters, at what position you want to insert, at what index you want to insert, and what value you want to insert. Then here, first condition, if position is 0, means you want to insert before head node. Then already we have seen what are the things we have to do. But here I have taken care of one more condition. See, here I have created a new node. Then in this statement condition I am checking, is it the first node? It will be a first node. If head is null, means it is the first node. If this is the first node, then head should point on that node and head's next should point on itself. Like already we have seen in previous video, if there is one single node, then head node will be pointing on itself. So that's what I have done. If head is null, means this is the first node. So I have taken care of that one. Otherwise, the procedure already I have shown you. There is no space, so I have combined more than one statements in a single line. So already you have seen the procedure. You should take P till the last node and this node should point on head and that last node should point on new node T. So all that procedure I have shown here. Else, if there is any other position, then this is the regular code for inserting a new node at any given position. So the same code is there. But one thing is missing in this code. Here I am not checking whether the position is valid or not. Like suppose 1, 2, 3, 4, 5 nodes are there. So I can give indices from 0 to 5, not beyond that. So I am not checking here whether the position is going beyond that one. If I am not checking what happens in this code, you try to analyze this one. right? When I write the program, that time I will include that condition also. I will check that also. Finally, analysis of insertions, that if you insert a new node after head, that is after first node, the time is constant, then it is growing and growing. At the last node it is n, or even before the head node also it is n. So there is one position where the time is constant. That's all about insert.